whereas the configurational or gestalt processing, obviously from configurational you know that it deals with the spacing and how your features are arranged on your face. Because you can tell that if someone's, someone that you knew that was familiar to you, their eyes were farther apart and their nose was higher and their mouth was down lower, they would look completely different than they do normally. So that is how we look at things, look at faces. And also what's kind of cool is that they've proven that people who are experts in an area, like car enthusiasts, use this gestalt processing when they look at a car, which is kind of cool because faces are like everybody's area of expertise, but you can kind of use this technique for, like bird watchers might do it with birds, or like real estate agents with the front of houses, things like that. So people can use this on different stuff, not only faces, but adults do use this when they look at another person. So a way that they kind of test with this gestalt and piecemeal processing is they'll take a face and they'll invert it and they'll flip it upside down. And so here we have a face, Prince William, and he's upside down and he's just hanging out. Does everybody agree that that just looks like his face has been flipped upside down? Okay, surprise, because when I rotate the picture, that's actually what his face looks like. Which is not so cute anymore. Because what happened, because his face is flipped up, well, I'll go to the next slide. Because his face is flipped upside down, you can't use the configurational processing because the configuration is thrown off because he's upside down. And so you have to revert to piecemeal processing. So looking at, okay, mouth, eyes, nose, he looks fine. But then when you flip it upside down, you can see your mistake in that his face is not normal. It's just not. And it is true that all objects are harder to identify or distinguish between if they're upside down, just because we're used to seeing things right side up. But faces, that difference is heightened because our brains are really sensitive to that. So there are kind of two ways of looking at facial recognition in terms of genetics and in terms of experience, and they kind of have those two schools of thought. But I think you'll see how they both kind of work together. Like there is a big genetic influence, but there also is a big component of experience that's in there. So we're going to talk about genetics first. The actual part of the brain that deals with facial recognition is the fusiform gyrus, which is down here. And they've done a bunch of tests through MRIs. Who knows what an MRI is, or can explain it pretty well? Yeah?
Oh, it's like you're in a little kind of almost like a tunnel thing, and they can, like, depending on what part they're MRI-ing, they can, like, see the inside of it. Like, I had an MRI done on my hand, and they could see inside, like, the bones and the wrist tissue and stuff. So.
Yeah, so the way that they do it with brains is they're looking inside your brain, basically, and they can see what areas light up with activity when you are presented with a different stimulation, I guess. So they'll show people pictures of faces, and this part, this fusiform gyrus just goes crazy. So they know that it definitely has something to do with that. And what's funny is that they do a lot of tests with monkeys, with facial stuff like this, and all brain stuff, because monkey brains are basically the same as human brains in a lot of ways. They would show a macaw a picture of another macaw, and the fusiform gyrus would just freak out, like it would activate. They would show it a picture of a gorilla or a chimpanzee, like a different kind of monkey, and it would activate, but maybe not as much. Show it a human face, not as much, but like a really scruffy human face, like a guy with a big beard, it would activate a little bit more. Or like they showed it like a scrub brush, like a toilet scrub brush, the really bristly ones, and it would kind of like flicker, like, well, like maybe that's a monkey. Which I just thought that was really funny that they tried all these different things to see how it would react. And so they did a bunch of, so scientists are trying to prove that this is the part of the brain that really does deal with facial recognition. So they did a bunch of different tests. These are MRI pictures, and you can see the color part. That one's the first one over there. That's the part that's activating. It has activity going on. So first one they thought maybe the fusiform gyrus is just involved in identifying objects. So you identify a face, maybe it's involved in identifying objects. But as you can see, where in the F section, the activation is way higher than it is in the O section, so faces versus objects. And then they said, okay, maybe it's just for facial features. Eyes, nose, when you see that, your fusiform gyrus activates. So what they did is they scrambled, hi, do you need anything? You're good with that. They scrambled a bunch of faces and showed those to the MRI people. But then you can see that the scrambled faces are consistently lower than the intact faces. They also thought, they hypothesized that perhaps it was because the fusiform gyrus activated because it was having to identify something that has a lot of detail in it. So houses have windows, doors, curtains, chimneys, a bunch of stuff. But faces, consistently higher again. They did it with, I think that one was when the patients had to do a task at the same time. I'm not sure what that was testing. And the hands was, is it just activating because of human, they see something from a human body. But from all of these, fusiform gyrus is activated higher when it sees faces, so we know that it's involved. Probably not the only thing involved, but at this point, we're pretty confident that it has something to do with facial recognition. So this is, prosopagnosia is kind of what I mentioned before when I said, imagine if you couldn't distinguish two people's faces. That's what this is. It's called face blindness. And people have different levels of it. It has something to do with the fusiform gyrus that we talked about just now. And so it could be that people just have a really hard time remembering faces, or they have to see them a lot before they can really internalize them, or they have to look at it for a long time before they can tell two people apart. Or it could be they have a hard time with unknown faces as opposed to familiar faces. There are also people, this is really, really rare, but if you have a really high, level of prosopagnosia, you can just, like face and chair, there's no difference. They're both just objects, and you can't distinguish those two things. And I think that's really bizarre, and I can't quite wrap my head around how that would work or look, but it has been documented. There's a, has anybody taken psychology, or is in psychology? Well, there's a book that we read, and it's really famous, and it's called, it has a bunch of cases, just psychological cases in it, and it's called The Man Who Mistook His Wife for a Hat. And that is kind of funny when you hear it originally, but it's an actual case of a guy with prosopagnosia who, I'm assuming, mistook his wife for a hat because he can't distinguish those two things. Also, some evidence for the genetic factor is that identical twins have similar brain activity in those MRI scans that we saw earlier. Their fusiform gyrus activates more similarly than fraternal twins, so they know there's some sort of genetic link with that. Oops, backwards. Okay, so this is kind of getting into the actual child development aspect of facial recognition. And so this study, what they did is they have two paddles, one with two dots and then one dot, which looks like a human face, and one with one dot and two dots, which doesn't look like a face. And they used babies, infants that were, I think, 30 minutes old, and then they also tracked it at intervals after that, but they started at 30 minutes, which is very, very little. And they would kind of hold the paddle like this and see how long they would track the, the paddle, the visual stimulus. And in all cases, the infant would track this face-looking paddle longer, significantly longer than the non-face-looking paddle, which is kind of evidence to suggest that right off the bat, from birth, we are wired to focus on faces and to look at them and know that they're important, and we're better at it. And also, they have found that biologically, babies have all of the basics that adults do for facial recognition. So the setup's all there, even though they haven't had that experience. We'll talk about experience later, but they haven't had that experience yet, so it's not as well developed, but it's set up to work the exact same way that adult facial recognition